Hello once again. This time we're going to have a look at AQA's Foundation GCSE Specimen Paper 2, which is a calculator paper. So for this one, we can use a calculator for every single question. So let's make a start talking through all the questions and seeing how we do. Question 1. Which of these numbers is one more than a multiple of 5? So multiples of 5 just is another way of saying the 5 times table. And so numbers in the 5 times table are going to be 5, 10, 15, 20, 25, 30, and 35, and so on, going on forever. But this question, we don't want a multiple of 5, we actually want one more than a multiple of 5. So the multiples of 5 I've just written out. I'm just going to write down one more than each of them underneath. One more than 5 is 6, one more than 10 is 11, one more than 15 is 16, one more than 20, one more than 25, one more than 30, and one more than 35 is 36. So from these numbers we can see that 26 is an option and 26 is listed here. 26 is one more than 5 times 5. And so the one we want to circle for question 1 is 26. Question 2. Which of these numbers has exactly 3 factors? So what we can do is just take them number by number. So question 2, we've got 4 different numbers. Let's think of the factors of 3 first. 3 only has 2 factors. We can only divide it by 1 and 3. Remember, factor means fit. What numbers fit into each number? So 3 just has 2 factors, itself and 1. Just let me make a little note. 3 is prime. If a number has only and exactly 2 factors, it's called a prime number. 5 would be prime as well. We can only divide that by 1 and 5. 6 we can divide by itself, which gives us 1. But also with 6 we can half it, we can divide it by 2, which gives us 3. So 6 has 4 factors. 5 has 2 factors because it's prime. 6 has 4. So we know already it's going to be 4, but let's just think why. We can divide 4 by 1, which is 4, and we can also half 4. But half of 4 divided by 2 is 2 again. So 2 is a repeated factor. So there are only 3 different factors for 4. And so the one we need to circle is 4. 4 has 3 factors, no more, no less. Question 3. Which of these numbers is 6 less than minus 1.4? Now, what this means, 6 less than 1.4, in terms of a calculation, what this means is minus 1.4 minus 6. So if you're unsure in any way for whatever reason, just remember it's a calculator paper, so we can use it if we want to. So first of all, minus 1.4 minus 6, we get this fractional answer. Press this button to change it to a decimal, minus 7.4. And so 6 less than minus 1.4 is minus 7.4. So we circle that one. Question 4. Which shape is congruent to x? Now, congruent is just one of these fancy mathematical words, which just means something fairly simple. Congruent just means exactly the same as. It means identical. So A, B, C or D, one of these will be identical to shape X, which I've got over here. And so you can see if X is the same as B. If we put it on top, it doesn't fit exactly. It doesn't fit on top of B nicely. So the only one it would fit on top of, which I'm going to try and show you now, if I just turn this slightly, it would fit on top of D. So hopefully you can see with D, X would fit perfectly on top of D. And it can only do that if it's identical to D. So for that reason, X and D are congruent. So it says circle the correct letter. We don't need to circle the shape. I'm sure the examiner would give you the mark anyway, but just circle the letter D, because D is congruent to X. Question 5. We've got a map showing the position of two ships, A and B. And it doesn't say the diagram's not drawn accurately. In fact, we've got a scale to work with. And so what we'll need to do is actually measure the distance on the map between A and B. So what we'll need here is a ruler. So if we just get our ruler and put the 0 point on A and then measure down until we're facing B. Now, be as accurate as you can. The examiner will give you a tiny bit of leeway, normally plus or minus 2 millimeters, but be as accurate as you can. And what you should find is the distance from A to B is about 8.7. So this distance here, if you see there, it's 8, 8.5, 0.6, 0.7. Now, if you're swearing blind that your distance is different, I'd suggest you do two things. One thing, check with your teacher. The second thing, make sure that the photocopying of your exam paper is exactly the same as the photocopying of this in the example. Sometimes photocopying settings are slightly different, which makes the images appear to be either slightly bigger or smaller. So it might legitimately not be 8.7 kilometers. Sorry, 8.7 centimeters. Jumping ahead of myself here. So I'll just have to rub out kilometers. My ruler's not so big it can measure kilometers. 8.7 centimeters, I should say. But as I'm trying to say, if you're not sure about your distance, get your teacher to check it. It could be that your distance is different to 8.7. But whatever you've got for this distance, we need to now apply this scale to work out what this distance would represent in real life. So the scale says 1 centimeter translates to 2.5 kilometers in real life. So to change from centimeters to kilometers, according to this scale, we're changing from a smaller number to a bigger number. The number we'll have in kilometers will be bigger than the number we've got in centimeters, because 2.5 is bigger than 1. So if we're converting from centimeters to the actual distance in kilometers, we're going to multiply by 2.5. If ever you've got two different values in a proportional relationship, where one of the units is given as a 1 and the other unit is given as not a 1, we convert by multiplying or dividing by the number that isn't the 1, in this case, the 2.5. So our measurement in centimeters was 8.7, and so what we need to do is multiply that by 2.5. 8.7 times 2.5. You should have got 21.75, or very close, if you have measured ever so slightly differently. So that's the final thing we need to put down. 8.7, get it in black, 8.7 multiplied by 2.5 equals 21.75 kilometers. Question 6. A gym has 275 members. Now, there's different types of membership for this gym. We could have a bronze membership, so 40% of these gym goers have a bronze membership, 28% are silver members, and the rest are gold members. Also an Austin Powers film, I believe. Pretty terrible. Anyway, these percentages relate to the total members. So first of all, the bronze members, we're told that 40% are bronze members. So 40% of 275 is what we need to calculate. So let's get our trusted calculator. Percentage always just means a number out of 100. Now your calculator does have a percentage button, but I'm just going to do it this way, just to stress that percentage means a fraction out of 100. So 40% means this fraction here of, multiply, 275 equals 110. And so for bronze members, we've got 110. So I'll just highlight that in yellow, as I did before. Now, 28% are silver members, so the same idea to calculate the number of silver members. So we're working out 28% of 275 here. So we do that in the same way we worked out 40%, same procedure, different percentage. So 28 over 100 multiplied by 275. And that comes to 77. So therefore we've got 77 silver members. The rest of the members are gold members. So if there's 275 members in total and the rest are gold members, we can just simply subtract the total number of bronze and silver members from 275. Now 110 plus 77 comes to 187, which were either bronze or silver. So what we can do now is subtract 187 from 275. So 275 subtract 187. Again, get the trusted calculator ready. 275 minus 187 gives us 88. So there'll be 88 gold members. And that's all for question 6. Question 7. Alan is looking at a number machine problem. So he says, if I know y, I can work out x. If I subtract 3, and then I add 5, does this method work? Give a reason for your answer. And so what he's saying is that if he knows y, he can work out x. So if we start over here with y, function machines can be reversed by going the opposite way and doing the opposite thing at each step. And so what you'd have to do is start with y. Going this way, he was minusing 5, so going the opposite way, he's going to do the opposite thing. Opposite of subtract is adding 5. And at this step, he was adding 3 going right, so going left, going the opposite way. Instead of adding 3, he'll do the opposite, which is taking away 3. And that's how he'll get x. So does this method work? Give a reason for your answer. Well, according to what I'm saying here, he should add 5 and then take away 3. He's saying take away 3, then add 5. And so it all hinges on, does the order of subtraction and addition matter? Just need to remind you of BIDMAS. Now your teacher might use BODMAS or something similar. But just to remind you what each letter means. So B stands for brackets. I stands for indices, which just means powers. For example, 2 squared or square root or something. D, M, A and S are more obvious. D is divide, M is multiply, A is add, S is subtract. And so what this is a running order of what you should be attempting first in a question. So if there are any brackets, sometimes there won't be, what we do first is we work out what the brackets are. Secondly, after doing the brackets, we then look at the indices and work those out. Now this can be taught confusingly, BIDMAS. Divide and multiply actually come as a pair, so you don't strictly have to do divide first and then multiply. You could multiply and then divide. So divide and multiply come as like the third pair. As long as you divide and multiply after the brackets and indices have been done, that's okay, and do them before adding and subtracting. And in the same way, addition and subtraction can be paired up together as well. So we've got 4 things to do, or 4 groups. So why am I saying this? Why am I going off on a tangent about BIDMAS halfway through explaining a 1-mark question? Well, it's going to be important for part B. The main thing I'm getting at is this will offer us an explanation as to if this method works or not. The answer is yes, his method will work. I'm saying add 5 then take away 3. He's saying subtract 3 then add 5. But because addition and subtraction can be grouped together with BIDMAS, the order you do them in doesn't matter. So does this method work? Yes. Reason: the order we add and subtract in does not matter. Now we're going to refer back to this BIDMAS in part B. And here is part B. So for part B, he says, if I know D, I can work out C. If I divide by 3, then subtract 5. So just looking at this number machine, if we start at D at the end, we can work back towards C. Again, like I said before, by doing the opposite process to what happened going the other way. So going forward, we added 5. Going backwards, we'll do the opposite and take away 5. And at this step, opposite of multiplying by 3, we'll divide by 3. And then we'd get C. So in this case, I'm saying we need to subtract 5 and then divide by 3, whereas he's saying divide by 3, then subtract 5. So does the order in which we divide and subtract matter? Well, actually it does, because divide is ahead of subtract in BIDMAS. They're not grouped together. Divide is the third group, subtract comes at the end. And so does this method work? No, it won't. The reason it won't work is we absolutely must subtract 5 then after that divide by 3. In this case, the order is important. Not like part A where the order wasn't important. This question, the order is important. Question 8, have to solve an equation. So it says solve 5w minus 11 equals 24. Now because I've got function machines on the brain because of a question before, question 7, I'm going to do this in two different ways. So the first way I'm going to show you is using a function machine. And so using a function machine, we can start with the letter we're trying to find out, which is w, and then just take it step by step and think what happens to the letter w. Well, the first number it bumps into is the 5. What's the 5 doing to the w? It doesn't say, but in algebra, if there are two things next to each other with no instruction telling us what's happening, it will always mean multiply. So that 5 is multiplying the w. After 5 multiplies w, then we take 11 away. And after taking away 11, that gives us our answer of 24. Now what we can do is start at the end, go the opposite way, doing the opposite things. So reversing it, instead of subtracting 11, we'll do the opposite of subtract, which is to add 11. 24 add 11 is 35. So just make a note of what that is before the next step. Then here, instead of timesing by 5, the opposite of multiply is divide. And so 35 divided by 5 will come out as 7. And so that tells us that w equals 7. Now I'll just show you another way just in case you're not a fan of this particular way. Now another way you can do most equations is by using the idea of swapping the side and swapping the sign. So we've got 5w minus 11 equals 24. Our objective is just to have w on its own. So what we could do is get rid of this minus 11 by putting it to the other side of the equals sign. But if we swap the side, we swap the sign. Opposite of minus is plus. So when the 11 moves over, we're going to add it on. 24 plus 11 is 35. And on the left hand side, after we've moved the minus 11, all we have left is 5w. What's the 5 doing to the w? It doesn't say, so it'll be multiplying the w. So if we swap the side, so we've got w on its own, we'll swap the sign too. Opposite of multiply is divide. So when the 5 moves over, it becomes a divide 5. So w will be 35 divided by 5, which is 7, like we said before. Part B. Write an expression for the total cost in pounds of X jumpers at £15 and Y shirts at £12 each. Now it's a 1-mark question, but these questions can read quite confusingly because it doesn't really make sense. You'd never go into a shop and buy X jumpers. You'd never go into a shop and buy Y shirts. You'd be using actual numbers, wouldn't you? So to put it into a more real context, first of all what I'm going to do is I'm going to just show you a table so we can just think it through a bit easier. So what we're going to do here is just imagine we're buying different numbers of jumpers and different numbers of shirts. So let's say we just bought one jumper. The cost is £15 each. So if it was one jumper, the cost of that would just be 15 times 1, which is 15. If we bought two jumpers, that'd be 15 times 2, which would be 30. If we bought 3 jumpers, that would be 15 times 3, which would be 45. So where am I going with this? Well, what I'm getting at is whatever the number of jumpers we're buying, we can work out the cost of those jumpers by just doing 15 multiplied by the number we happen to be buying. So it would be 1, 2, 3, a million, or even X. If we were to buy X jumpers, it's exactly the same idea. Instead of 15 multiply 1, or multiply by 2, or by 3, we just do 15 multiplied by X, which is 15X. So the cost of X jumpers at £15 each is actually just 15X. We can follow a similar idea for these shirts as well. So let's imagine we're just buying one shirt. Each shirt's £12 each. So one shirt would just be £12 times 1, which is obviously just 12. Two shirts would be £24. That's 12 times 2, which, as I just said, is 24. Three shirts would be 12 multiplied by 3, which would be 36. But again, it's the pattern I'm interested in. All we're doing each time is multiplying 12 by the number of shirts we're buying. It makes more sense when you put it into a real life context. So just follow the same idea if it were Y shirts. What have we done before? We've just took 12 and multiplied it by the number of shirts we're buying. So if it's Y shirts, it would be 12 times Y, which will be 12Y. So the cost of Y shirts at £12 each would just be 12Y. So the total cost of the jumpers and plus the shirts would be 15X plus 12Y. Just to remind you where I've got these numbers from. 15X from this table and 12Y we mentioned from down here. So all that's left is to just write this solution on our answer line. 15X plus 12Y. Part C, we have to simplify x plus y multiplied by y. So what we need to realise here, we've got two different terms. We've got x's, which we're adding together, and we've got y's, which were being multiplied together. X plus an extra x would give us two x's. But for y's aren't being multiplied together, for y's aren't being added together, for y's are being multiplied together, I mean to say. Y multiplied by y, if we're multiplying something by itself, that's y squared. So x plus x becomes 2x, y times y, it becomes y squared. And so this one just becomes 2x plus y squared. Question 9. Lucy says 3 is odd and 2 is even. So when you add a multiple of 3 to a multiple of 2, the answer is always odd. Is she correct? The quick answer is no. No, Lucy, you're not. Try again. But seriously, no. You need to give a calculation to support your answer. What this is called, you're looking for a counter example. You're looking for something which proves her wrong. So what she's claiming here, if we just highlight what she's actually saying, when you add a multiple of 3 to a multiple of 2, the answer is always odd. So if you just think now of multiples of 3, and also multiples of 2, Multiples of 3 just means numbers in the 3 times table. So 3, 6, 9, 12, 15 and so on. The multiples of 2, 2, 4, 6, 8, 10 and so on. Now if you have a look here, we'll be able to find a different example which shows her to be wrong. So for example, it won't always be odd. For example, we could pick an even multiple of 3. For example, we could pick 6 added to 4, which is 10, and 10 is even. So for this one, we could pick a multiple of 3. If we pick an even multiple of 3, in this case 6, and add that to any multiple of 2, in this case I've just picked 4 for the hell of it, that will give us an even answer. So that proves that she's wrong. So one thing is to say no, second thing is to give an example of why she is wrong. Question 10. Tom earns £9.20 per hour. He works for 24 hours each week, 48 weeks in each year. He pays tax if he earns more than £10,000 per year. Does Tom pay tax? You must show all your working. There's a few ways of doing this question and working it out. What I'd suggest is we could work out his weekly pay first. So he works, according to this question, 24 hours in each week. He also gets paid £9.20 per hour. So for 1 hour, you get paid £9.20. So for 24 hours in a week, he'd get paid this for 1 hour multiplied by the 24 hours he works. So £9.20 multiplied by 24, let's see what that comes out to be. So £9.20 multiplied by 24, per week he gets paid £220.80. So let's just write that in. So each week, that's his take-home pay, £220. But it next says he works 48 weeks each year. And so what we need to do now is we need to take his weekly pay, which is 220. Just go back, that was a bit of a mess. £220.80. And multiply that by 48, because he works 48 weeks in a year. So let's see what that comes to in total. So £220.80, multiply that by 48, and it comes out to be £10,598.40. And that's his full pay for a year. Now the question's just asking if he pays tax or not. It's not asking how much tax he pays, but it does say he pays tax if he earns more than £10,000 per year. This calculation shows that he's above the £10,000 limit, so our final answer is yes, he's going to pay tax. For the simple reason that £10,598.40 is greater than 10,000. So yes, he pays tax. Question 11. 3 boxes contain counters. It says there are 62 counters in total. The total number of counters in box A and box B is 34. That's the key bit of information to get us started off. So in box A and box B combined, there's 34. So the rest of them must go in box C. So there's 62 counters in total, 34 of which are in box A and box B. So 62 take away 34 will tell us how many must be in box C. So if we get the calculator to hand and do 62 take away 34, we get 28. So that tells us box C has 28 counters in. The next thing it says is that the difference between the number of counters in box A and box C is 9. It doesn't say if box A has 9 more or 9 less, so what we could do is just try both options. So maybe it's 9 more. Now if there were 9 more in box A, there'd be 28 plus 9, which should be 37. But there's also 28 in box C, which we just worked out previously. So just box A and box C, that come to 65, but there's only 62 counters in total. So there can't be 9 more counters in box A, therefore it must be 9 less. So what it'll be is 28 take away 9, which is 19. And so what we did is 28 take away 9 to get 19. Finally, we can work out how many must be in box B. So box B, well, there's 19 and 28 in A and C. 19 plus 28, what does that come to? 19 plus 28, may as well use a calculator. Why not? 19 plus 28 is 47. And so we can work out how many counters are left by doing 62 subtract 47. 62 take away 47. What does that give us? 62 minus 47 gives us 15. And so that's how many counters are in each box. We've got 19, 15, and 28. And so that question 11 is now done. So let's have a look at question 12. Question 12, it says that the pie chart shows information about the sales of 800 tickets. There are twice as many adult ticket sales as senior ticket sales. I'm going to do this question in two different ways. I'm going to give you the standard way of doing it. I'm also going to give you another method which, if you forget in the exam or you have a bit of a panic, I'm going to give you a trial and error approach which will get you the answer without having to remember what I'm going to show you now. But this is an emergency approach, so try to understand the first one if you can. Anyway, question A, show that there were 140 senior ticket sales. Well, let's have a look at the information we've been given so far. It's a pie chart which looks like a circle, so a full circle, a full pie chart, you should know, will be 360 degrees. That's worth just noting down just as a little reminder, if nothing else. A full circle is 360 degrees. So what fraction of this pie chart is a children's slice? It's 171 degrees out of the total of 360. So we can calculate directly how many children there must be. The fraction of children of the total will be 171 out of the total 360. Now the total tickets was 800. So if we work out this fraction of 800, we're told there that we have 380 child tickets. And so if we write that down just for calculation we've done, as evidence for Mr. or Mrs. or Miss Examiner, 171 over 360 multiplied by 800, that tells us, or that told us, that there were that many child tickets. Oh, I've rubbed off how many children there were now, but there were actually 380. So that comes to 380 children. So how many children? Answer is 380. And we got that by doing 171 degrees, which we got from here, and the fact that there were 800 tickets in total. So 380 were children's tickets. How many tickets were left? So the number of tickets remaining is 800 subtract 380, which is 420 if you were to work it out. 420 other tickets. Now these other tickets must either be for seniors or adults. It says there are twice as many adult ticket sales as senior ticket sales. So we can split this and think of it in terms of a ratio. So in terms of adults to seniors, you can think of it as a ratio. There are twice as many adult tickets as senior tickets. So that means for every one senior ticket, there were twice as many adult tickets. So 2 lots of adult tickets for every 1 lot of senior tickets. 2 plus 1 is 3 lots altogether. And so we can split 420 into 3 pieces. 420 divided by 3 will equal 140. And so the number of senior tickets we've got 1 lot of 140 senior tickets. Senior tickets 1 times 140, which is obviously 140. 2 times 140 is 280. So 280 adults, 140 seniors, and 380 children would give you a total of 800. So that's how you could maybe double check your answer. Now I'm going to give you a slightly different method, which I'm not advising unless it's an emergency, but just to show you the same question again done a different way. I've got here a table of values. I'm going to explain what's happening. As long as you can remember that a pie chart or a full circle is 360 degrees, if all else fails, trial and improvement is something to fall back on. So this is why I want to mention it, not because I'm recommending you do it first of all, but I recommend remembering it's always something to try if you're really stuck. So what we need to realise is the child angle plus the adult angle plus the senior angle has all got to add up to 360 degrees. So the child's angle is 171. I mean, we're told that already. There are twice as many adult ticket sales as senior ticket sales. So what that would mean is the adult sector, the adult angle, will be double the angle for the seniors. And so what I'm suggesting is, if you're not sure, well, make something up. Let's say maybe the adult angle, sorry, the senior angle was 10. The adult angle is always going to be double. So if it were 10 for seniors, double 10 would be 20. Then check, does this add up to 360 degrees? Well, let's just see. 10 plus 20 plus 171, 201. So 201, that's too low. So no, we need to make it higher. So let's try something a bit bigger for the senior ticket angle. Maybe the seniors was 40 degrees. That would make the adult angle double that. Double 40 is 80. And again, as ever, the child angle is 171. Let's see if this comes to the correct total. 40 plus 80 plus 171 291. So still a bit too low because it's not added up to 360. So let's try going a bit higher. Maybe 70. Double 70 is 140. Remember, the adult angle will be twice as big because there's twice as many adult tickets. And the child angle will always be 171 because it tells us. Let's add these up. 70 plus 140 plus 171, 381. Now that's a bit too high. We've gone over 360. So what we need to do is lower this one slightly. So I don't know, maybe try 65 degrees. Double 65 is 130. And that would be 171. Let's see if that comes to 360. .366, pretty close, but still a tiny bit too high. So just lower ever so slightly. Maybe it's 64. Double 64, 128, and 171. If you're thinking, why on earth is he doing this? Why is he telling us to guess? I'm just saying, if all else fails, if you're stuck at the end of the exam twiddling your thumbs thinking, I've tried everything I can, I'm just trying to give you some ideas of what you might be able to try if all else fails and you're really, really stuck. There's always something you can do. That comes to 363, which is still a tiny, tiny bit too high. So let's just make it 1 degree less. Let's make it 63 degrees. That's 126. And once again, the child's angle, 171. Will this work? 63 plus 126 plus 171 equals 360. So, finally, we can say that works. Big smiley face, we're relieved. And so, 140 senior ticket sales, we now know that the senior's angle must be 63. So now we know that, we can do a quick calculation to work out what fraction the seniors will be. So the fraction of the pie chart for the seniors is 63 degrees as a total of 360. So it's going to be that fraction of the total ticket sales, which is 800. So if we calculate this, now the first way I didn't even bother working out the angle for the seniors, so it just goes to show how many different approaches there could be for any one question. So that fraction of 800 equals 140, and that proves, therefore, that there must be 140 senior ticket sales. It all checks out and it all works. Question 12, part C. So using what we've worked out for A and B, we need to be drawing a bar chart on the grid to represent the child, adult and senior ticket sales. So from parts A and B, the child tickets we worked out was 380. The seniors was 140, and the adult tickets was double 140, which was 280. And so what we're going to have to do here is to draw a bar chart of this data. So what we'd need to do first of all would be to pick a suitable scale to go up for in our y-axis. So as long as it fits on the grid, it doesn't really matter what scale you use, as long as you're comfortable using it. So the biggest value is 400, so as long as we can fit 400 up here, we'll be doing fine. So what I'm going to suggest is, what we could do is go up in 50s. So just marking off each lot of 5 squares could be worth 50. So just going to put a 0 line here. Now we could have started right at the bottom, that would have been fine as well. But that could be 0, 50, 100, 150, 200, 250, 300, and finally at the top 350 and 400. So each little square is worth 10. You also need to label each axis. So on the scale going upwards on the y-axis, this is the number of tickets sold. So that needs labeling. Tickets sold. The x-axis is always the sort of things you're measuring. The y-axis is the measure, is the numbers. The x-axis is the things which you're measuring. So these are going to be types of tickets. And so the types of tickets we've got, we're going to have child tickets. So need a space for child tickets. Also going to have adult tickets. And also senior tickets. And this needs labeling, something along the lines of type of ticket. Just so somebody who's not familiar with bar charts or this question would be able to understand it clearly. So they know what you're talking about. Now, using a ruler, the child tickets are 380. And so we start off here, go straight up until we get to 380. So depending on your scale, yours might look different, that's fine. That's 360, 370, 380 would come up to here. Do a line going across, and then a line coming down. So that's for child's tickets, 380. The adult tickets, we had 280. And so going up to 280, stopping there. Same at the other side. Importantly as well, when we do a bar chart, the bars need to be equally spaced out and each bar has to have an equal thickness. That's very important. So each bar should be the same width as each other and they should be equally spaced out. The senior tickets, we have 140, so it's 140. Exactly half the size of the bar for the adults. And so that would do. Doesn't have to be particularly beautiful looking or neat, you don't have to colour it in. That'll do the job and that will get you the marks. So, question 13 about Alice making ribbon. Sorry, Alice is making cards using ribbon. So you read the question, that goes for me as well. Each card uses 42 centimetres of ribbon. She's got 1,000 centimetres of ribbon to use. Work out the maximum number of cards she can make. It's essentially how many lots of 42 she can cut out of 1,000 centimetres of ribbon. So this is essentially going to be a division question. What we need to do as a main calculation is 1,000 divided by 42 and see what that gives us. So 1,000 divided by 42, that's 23.809 whatever. The point is how to interpret this answer. What this means in plain English is you can make 23 whole bits of ribbon and a bit left over. So the decimal part of that number represents the remainder, whatever's left. So 23.8, almost 24, but not quite. So the maximum number of cards she can make, because she can use 23 lots of ribbon, with that she can make 23 cards. How much ribbon will be left over? For this one, the easiest thing to do, I would suggest, would be to work out the total length of 23 pieces of ribbon. Each piece of ribbon is 42 centimeters. So if we do 23 multiplied by 42, that would tell us how long in total the bits of ribbon are that she's using. So 23 multiplied by 42 is 966. So she's used 966 centimeters of ribbon. So whatever's left from the 1000 tells us how much ribbon is spare, how much ribbon she's left out. So that's 1000 take away 966. May as well use a calculator if it's a calculator exam. That's 34. So the final part of this question is that there's 34 centimeters left. Question 14. Luke's saving 10p coins and 10p coins. 10p coins and 20p coins. So he has 3 times as many 10p coins as 20p coins, and he's got a total of £17. How many 10p coins does he have? I'm not going to go into a trial and improvement method here, but I'm going to mention that it would be a valid method to use. So what you could do, for example, if you wanted to, or if you're really stuck, would be to guess your way systematically to getting the right number of 10p and 20p coins. 10p coins and 20p coins can only be whole number values. You can't have half a coin or a third of a coin. So you could, for example, just try something for 20p. Maybe he's got 10 20p's. He's got 3 times as many 10p's. Times that number by 3, which should be 30. Work out on your calculator how much money that would come to. If it was higher than £17, try something lower. Try fewer coins. If this was too low, try more coins. So maybe try 20 and 60. But anyway, I'm not going to get into that method, but it's worth a mention. Now, what I'd suggest would be to just start off thinking, what if we just had one 20p coin? If you had one 20p, he has 3 times as many 10p coins as 20p coins. So if you had one 20p coin, that would mean he has 3 10p coins. How much money would that give him in total? Well, one 20p is 20p, obviously, plus 3 lots of 10p's. That'd come to 50p, which is obviously too low. What we can do is just build it up systematically to £17. So if that's 50p, we could easily get to £1 by just doubling our values. 2 lots of 50p will get us to £1. But if we double this, we'll need double the number of coins. So 1 times 2 and 3 times 2. So if we had 2 20p coins, 3 times as many as 2 is 6. Like I said, 3 times 2 anyway. That would give us £1. Feel free to check it. 2 20p's would be 40p. 6 10p's is 60p. 40 plus 60 gives you £1. But obviously we don't want £1. We want the total to be £17. So how do we go from £1 up to £17? What do we need to multiply 1 by to get 17? Well, the answer is we can just take £1 and multiply by 17, because 1 times 17 is obviously 17. And again, in the same way, if we multiply this by 17, we do the same to the numbers of coins. If we want 17 times as much money, we need 17 times as many coins. So multiply the number of 20p's by 17, and the same for the number of 10p's. So 2 times 17 is 34. 6 times 17, I think, is 102, but let's just double check. 6 times 17 equals 102. And so, when the question says, how many 10p coins does he have? We've just worked out that he must have 102 10p coins. Question 15. A company has bikes for hire. The cost in pounds to hire a bike for n days is given by the formula here. C equals 12 plus 27 over 4 brackets n minus 1. Write down the cost to hire a bike for 1 day. And so n is the number of days, which is here. And so 1 day, all that means is we're using n equals 1. Now we could substitute n equals 1 and worry about brackets and things, but if you've got a calculator which is good enough, which you're comfortable enough with using, we can just type this in exactly as it says. The understanding part, if n is 1, 1 take away 1 is 0. So this multiplied by the brackets, which is 0, is just nothing. So all this will disappear, and all we'd be left with is just this 12 on its own. But don't take my word for it. The safest thing to do, if you're not sure, is to use the calculator. Bracket, because it says bracket. N is now 1. And type in minus 1. So we're using the formula exactly as it appears. Press equals. And we see that the cost for 1 day would just be £12. Part B, we've got a special offer here. And is it cheaper to hire a bike for 7 days using the special offer or not? You must show you're working. At this point, it's worth reminding ourselves that there is like a standard offer from Part A, which was this. And so we're talking about 7 days. If you're talking about 7 days, then n is going to be 7. So what we're going to do is just compare the special offer. Don't want a yellow pen, I'll have a black pen please. Special offer versus the standard offer. The special offer is easy to work out. £9 per day for 7 days. We just need to do 9 times 7, which is £63. Whereas this standard offer, because n is 7, is going to be 12 plus 27 over 4 brackets n minus 1. Well, n will be 7. So what we can do is again just use the calculator to double check and save us from panicking, and just type in this formula using n equals 7. So in fact I can be a lazybones and just edit what I had before. For part A, n was 1, so I'm going to delete that and just put n is 7. Press equals 52.5. Now that's £52.50. So in this case, it's not cheaper to use the special offer because the standard offer is about £10 cheaper anyway. So is it cheaper to use a special offer? The final answer, based on the working, is no. It's not cheaper to use a special offer in this case. And part C shows a graph of a cost to hire a bike for 1 to 5 days at a different company. And so we've got a formula here. It says work out the values of A and B. Now, if we go back to part A of the question, just reminding ourselves when n was 1. When we had 1 day, the cost was just the number on its own. So we can use the same idea here. If n is 1, all this disappears because it's n minus 1. And the same holds true for part C. If n is 1, 1 take away 1 is 0. So b multiplied by what's in the brackets, which is 0, is just nothing. So what I'm trying to say is when n is 1, the cost will be A. So let's go on the graph and find out where n is 1. So on the graph, n is 1 here. And the cost, if we read off at that point, is 9. So the cost equals A, which is £9. And so from that, we can work out that A is £9. So that makes it much easier. Now what we can do is just pick a different value for n. So how about n is 2? When n is 2, we can use a graph to work out what C would be. So when n is 2, go up and along, then along this point here, and that point is 17. So when n is 2, C equals 17. So just to remind you, I got this by just reading the graph from here, going up and along. So now what we can do is use this formula. So when n is 2, C is 17. And so C, which is 17, equals A, whatever A is. Well, A is 9, isn't it? So actually we can replace A with 9. So 17 equals 9 plus B, brackets 2 minus 1. There's nothing in between B and that bracket, so it means B is being multiplied by what's in the bracket. BIDMAS. Work out the brackets first if we can. So just giving ourselves a bit more space. 17 equals 9 plus. Now, the brackets is just 2 minus 1, which is 1. And so B multiplied by 1 is just B. So 17 equals 9 plus B. So 9 plus some number equals 17. B has got to be equal to 8. Again, we can treat it as an equation and swap this 9 to the other side. And when we move it to the other side, it becomes a minus. So B is 17 minus 9, which is 8. So A is 9 and B equals 8. And that's quite an awkward question, in my opinion. Question 16, we're talking about a company's logo, and we've got some information about it. So it's a pentagon, has exactly one line of symmetry, has sides with whole number lengths, and has a perimeter of 15 centimeters. Draw a sketch of a possible logo. What we need to do first of all is remember what a pentagon is. A pentagon is any five-sided shape. Okay, so I'll show you the pentagon I've got that I made earlier. So here it is. Okay, now a slight digression, but I'll give you a little way of how I used to remember a pentagon was called a pentagon. Pentagon, be thinking of penthouse. So a penthouse is the name of a type of house. But just imagine, back in primary school, the easiest way you could draw a house. The easiest way you could draw a house would be 5 sides. There's the chimney. This is the roof. There's your door, windows, and so on. As you can see, I'm not a very accomplished artist, but pentagon, penthouse, the easiest way of drawing a house with a roof would be to use 5 sides. Anyway, enough of my terrible artwork. Let's just get rid of all that. Importantly here, it says it's got one line of symmetry. So for that reason, it can't be a regular pentagon. Regular shapes have the same numbers of lines of symmetry as the number of sides they have. So a square's got 4 lines of symmetry, a pentagon's got 5 lines of symmetry, a regular hexagon has got 6 lines of symmetry. By regular, I mean when all the sides are exactly the same length. And so what it can't be is as it is right now. This is a regular pentagon. And so what we might want to do is just imagine it maybe squished in slightly. If it was squished in, then it would still have one line of symmetry, but by squishing it, what we'd do is we'd take away the other 4 lines of symmetry. There'd just be one line of symmetry going down the middle. So I'm just going to label that the line of symmetry. Now in terms of the sides could be lots of different things. The only thing that matters is the total perimeter is 15 centimeters. That means that the perimeter all around each 5 sides needs to add up to a total of 15. And so as long as each opposite side is the same length, because it's symmetrical, and all the sides aren't the same, we've got multiple different choices we could have. So one choice could be, this top one might be 3 centimeters. We should make this opposite one also 3 centimeters. This one here, I know it doesn't look like it because I've drawn it just so badly, but just say sketch, that could be 2 centimeters. And this one would be 2 centimeters as well. 3 plus 3 is 6, 2 plus 2 is 4, 6 plus 4 is 10, so maybe the bottom one is 5 centimeters. That would be one possible way of doing it. I know it's terribly drawn and not to scale, but that would do. 3, 3, 2, 2, and 5 could be possible sides of a shape. There are many different combinations as well. We could have had, for example, 4, 4, 4, 4, and that bottom one could be 3. So just because you've not got the same sides as me, isn't say you're necessarily wrong. Question 17. This is a big question, 5 marks. What I'm going to draw your attention to first, though, is just how many conversions you need to be doing for this question. The first thing it mentions is that petrol is £1.27 per litre. So that's a conversion between price and litres. It then mentions as well about the car. So 32.3 miles per gallon of petrol. That's a conversion between number of gallons and how many miles that number of gallons will get you to drive. And there's also a final conversion between gallons and litres. So I'm just going to reveal down here the conversions I've set out in advance. The important thing to notice about all of these conversions is these conversion relationships are all in the same form, in that for each one number is 1 litre, 1 gallon, 1 gallon, and the other number is a number that isn't 1. If ever you have a conversion where one number's 1, the other one isn't 1, we convert from one unit to the other by multiplying or dividing by the number that isn't 1. You wouldn't times or divide by 1 because that would get you nowhere. So for example, litres to pounds. 1 is a smaller number than 1.27. So we're going from a smaller number to a big number. To change from litres to pounds, we'd multiply by 1.27. So going the other way round, going the opposite way, we do the opposite thing, which should be to divide by 1.27. This one, from gallons to miles, is going from a small number to a bigger number. The mile number is bigger than the gallon number. So if we're changing from gallons to miles, we'll be multiplying by 32.3. So to change the other way around, from miles to how many gallons you'd need, opposite way, opposite thing, that would be dividing by 32.3. Final conversion, from gallons to litres, the number of litres is a bigger number than the number of gallons it represents. So going this way would be multiplying by 4.5. So you might have guessed it already. To go the other way round would be to divide by 4.5. So I've just set out the conversions we might need to use in advance so we can refer to these at the bottom later on. Anyway, 5 marks. Let's just pick up marks that we can. So the easiest mark to pick up, I'd say, is just looking at the first bit. He works 5 days each week. So, 5 days each week. If he uses his car to travel to work, each day he'd drive. Just notice that. Typing mistake. It should be he drives a total distance of 24.2 miles. Terrible. Each day he drives a total distance of 24.2 miles. So, if he's travelling 5 days a week, the total distance he travels in a week would be 5 times 24.2. So, let's just do that on our calculator. 5 times 24.2. It'd be 121 miles each week. So that's our first mark on the board. So the car apparently needs 1 gallon of fuel for every 32.3 miles it travels. We know he's going to be travelling 121 miles in a week. So how many gallons would he need? So we're looking at this conversion here. To change from miles to the gallons required, we're going to be dividing by 32.3. And so 121 divided by 32.3 will tell us how many gallons he needs. So let's just use a calculator. So 121 divided by 32.3 gives us this number here. Now, don't round off too soon in calculations. If you're going to round off answers, only round off at the very, very end. So keep plenty of numbers at this stage. So that's 3.74613-ish gallons. Don't be scared of writing down lots of numbers. The more numbers we keep, the more accurate we'll be. If you round too soon, you lose accuracy midway through the calculation. So that's how many gallons that are needed for his weekly travel. So we use this conversion down here. But obviously, in this country, we normally pay per litre. In America, it's by gallon, or so I hear. So 3.74613 gallons, how can we change that to litres? We're going to use this conversion here at the bottom. So before we used a gallons to miles conversion, which was this one. Now what we need to do is change from gallons to litres. Now from gallons to litres, we multiply the gallon number by 4.5. So 3.74613 ... gallons. If we multiply that by 4.5, that will tell us how many litres he's going to be using. So again, using the calculator, that number here, which I've already got, multiply it by 4.5. That tells us that he's using about 16.85759-ish litres. So just write down as many numbers on your calculator as you want to. The more the better at this stage. So 16.85758 ... litres. Now, how much does each one of these litres cost him? Well, each litre costs £1.27. So to change from litres to the price, we're going to multiply how many litres is used by 1.27. So now 16.85758 and the rest of it, whatever the number was, multiply it by 1.27. That'll nicely change it into how much money that petrol will cost him. So this number here multiplied by 1.27 is £21.409. So when we get to this stage now, we may as well round to the nearest penny. Less than a penny in real life terms is meaningless. So just round to the nearest penny, 21.40, but next to the 0 is a 9. So 40 will round up to 41, because next to the 0 is a number 5 or bigger. So to the nearest penny, it's going to cost him £21.41. But if he uses a bus to travel to work, he can buy a weekly ticket for £19.50. So the final question here is a yes or no based on this working. Is it cheaper if he uses his car or the bus? Well, the bus is only £19.50, the car's £21.41. So to answer this question, it would be cheaper to use the bus. Not to mention much more economically friendly. So yeah, get on the bus, use the bus, it's cheaper. Let's do something about our carbon footprints. Question 18. This is a pretty tricky question, I think. Pretty tricky indeed. We've got two number machines, A and B, and it says both machines have the same input, and we need to work out the input that makes the output of A 3 times the output of B. And so it's really tricky knowing even where to start this one. But if we say the output of B, B's here, so if we call this output of B, just call it B. And if the output of A is 3 times this, 3 times B, we could say this is 3B. So they have the same input as well. So we can call the input whatever we want. So for the sake of argument, we could call the input in this case x. X tends to come up a lot in algebra in terms of letters. So this time they both have the same input, and we're going to call this input x. Now, using these number machines, we can generate an equation from A and from B. So the equation from A, x comes along, is multiplied by 7. X times 7 means 7x. And then we take away 4, and the outcome of that is that we get 3b. And from the bottom number machine, x gets multiplied by 3. This one's 3x plus 2. And that one equals b. So now knowing what to do, as I say, is slightly tricky, but what we could do is we could substitute in what b is into the top equation. So if you have a look at the top equation, we're told what 7x minus 4 is. It's worth 3b. But we're also told that b itself is 3x plus 2. So using this equation here, what we can craftily do is substitute in what b is in terms of x. So we're going to leave this bit as it is, leave it as 7x minus 4 equals 3b, but we're going to substitute in what b is in terms of x. We can say b is 3x plus 2. Because that's what we're told by thinking of this number machine at the bottom as an equation. So using this, we've now got an equation to solve, quite a hard equation involving x. So the first thing to do would be to expand the brackets. So we expand brackets by multiplying what's on the outside by what's on the inside. So first of all, we do 3 times 3x, and then we do 3 times 2. 3 times 3x would be 9x. 3 times 2 would be 6. So this is a bit more solvable now. The only trouble is, we've got unknowns on each side of the equation. What we need to do in these cases is to have all of the letters on one side, all of the units on the other. So what I suggest us to do as a first step would be to move the smallest number of x's to join the biggest number. The smallest number of x's is the 7x. These 7x's are positive. So if we swap the side of them, if we swap the side of the equation, we swap the sign. These positive 7x's will be taken away from the 9x's on the other side. So what we'd have here now is minus 4. 9x, take away the 7x we're moving. We'd have 2x's left, plus 6. Our objective is to have x on its own, so we could get rid of this positive 6 by again doing the same thing and swapping the side. But if we swap the side, we swap the sign. So this positive 6 will become a minus 6 on the other side. So what will happen is on the left hand side of equals, we'll now have minus 4 take away another 6. If you're getting confused with negatives, just always remember this is a calculator paper, so is minus a plus? No, it isn't in this case, because minus 4, minus 6, the two minus signs are separated by the 4 in the middle. Minus a minus only makes a plus when the minus signs are together and touching, but I digress. Minus 4, minus 6 that gives us minus 10. And so minus 10 equals 2x. The final step, we want just 1x. That 2 can go away. What's the 2 doing to the x? If there's nothing telling us what's happening, it always means an invisible multiply. So again, when we swap the side, we swap to the opposite sign, which is divide, because opposite of multiplying is divide. So x is going to be minus 10 divided by 2, which will be minus 5. So just remember at the beginning, the input was x. So x is the input, which we just worked out is minus 5. So that's our final answer, which is pretty hard, I think. The input would have to be minus 5. It's not even an easily guessable answer at all. Even trial and error would be hard because it's a minus value. Very difficult question, that one. Question 19. Joseph runs 400 meters in 1 minute. He assumes he can run any distance at the same rate. Just think about that for a second. And just remember the word assume. Normally, well, not always, but if you assume, you run the danger of making an ass out of you and me. Assume. That's something I was once told. It just basically means when you assume, you're in danger of getting something massively wrong. So this is a big word, assume. Well, it's only 6 letters. I mean, it's big in a metaphorical sense. He reckons, because he can run 400 meters in 1 minute, he could run 10,000 meters in 25 minutes. So let's just think about what he's saying. 25 minutes is 25 times as long. So maybe, yeah, he could run 25 times as far. So let's just try that. 400 times 25 equals 10,000. So it's very tempting to say, yeah, Joseph, you must be right. 400 times 25 equals 10,000 meters. So you'd be thinking that perhaps he's reasonable. But just think about it. 400 meters in 1 minute. The shorter the distance, the faster you can run at. For example, Usain Bolt can run, or could run, 100 meters very fast indeed, but you can't keep that speed up for very long. You can only keep that speed up for seconds. So in 25 minutes, Joseph's a human. He's a human being. What will happen? He'll have to slow down. He can't keep that speed up for very long. So although the assumption is tempting to tick, yes, he's right, actually no, the time will be longer. This is why you need to apply the maths to real life. So there's a working, and the reason is his assumption is incorrect. So something then following along the lines of he'll get tired and need to slow down. So he can't keep up his fastest pace forever, or he'd get tired. Just something along those lines. You don't need to word it exactly as I'm doing, but you know, Joseph, he's not a car, he's not a Terminator, he's a human, he's going to get tired, and people will slow down in time. 25 minutes is a long time to be running very, very fast for. You can jog it, but run it, nah, I don't think so. So, question 20. Which sequence is a geometric progression? Well, the word geometric in itself is potentially confusing. So what I've done, I've just taken the liberty of explaining what a geometric progression is. So a geometric progression, all it means is a sequence where each number, numbers are called terms, is found by multiplying the previous term by a fixed value that doesn't change. So it might be when the numbers are doubling each time, or it might be where they're tripling each time, and so on. So 1, 2, 3, 4, these just getting bigger by 1. We're just adding 1 each time. So the rule for that one is add 1 each time. So that's not. This one here, plus 1, plus 2, plus 3. So again, we're not adding a fixed value. We're not even multiplying by a fixed value. 1 times 2 is doubling. Double 2 is 4. If you double 4, you'd get 8, not 7. So it can't be that one either. But if you have a look at this one here, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. These numbers are doubling. So this one here is a sequence where, as described earlier, each number is found by multiplying the previous one by a fixed value. In this case, each number, you take the previous one and double it. So the fixed value here is 2. 1 times 2, 2 times 2, 4 times 2. The next number would be 16, then 32, and so on. The numbers are doubling each time. So that's why this one is a geometric progression. Question 21. A pyramid has a square base. So by square base, it just means the bottom of it is square shaped. Like this. And we're given kindly a formula for the volume of a pyramid, which is 1/3 multiplied by the area of a base times the perpendicular height. Now the perpendicular height just means the height going straight upwards, which we've been told is 17.4. Area of a base is what we need to work out now. Now the base is a square, so by area of a base, what it's asking us to do really is work out the area of the square. Area of a square is the length times the width, like a rectangle. But for a square, the length is the same as the width. So if this is 12.9, this one will be 12.9 as well. So the area of a square will be 12.9 times 12.9. 12.9 squared. That's where the term squared may well come from. So this one, 12.9 times 12.9 equals 166.41. So the area of a base, which is the same as the area of a square, because the base is the square, is 166.41. So what we can do now is apply this to the actual question. So the volume of a pyramid, actually leave it over here again. There we go. We can see everything we need to now. Volume of a pyramid, we can type this in on our calculators. So it's 1/3 multiplied by the area of a base, which we've just got here, 166.41, multiplied by the perpendicular height, which we're told is 17.4. So then we just press equals, then convert to a decimal form, we've got here the volume is 965.178. Now, if you wanted to, you could round that off to something reasonable, like the nearest whole number, 965, or to one decimal place, 965.2. If you're really not sure, and the question doesn't tell you what to round it to, feel free to just write down the whole answer if you're not sure. But anyway, for volume, how we did that, show the examiner what we've pressed. We did 1/3 times the area of the base times the perpendicular height, and I think I'm going to choose to round mine off to 965.2. Not that you'd have to, you could have kept all the numbers if you wanted. So all we're doing there is just using our calculator and plugging in the values into a formula as required. Area of the base times perpendicular height with 1/3 banged on at the front. Question 22. A Venn diagram question. So E, the fancy curly E, means everything. So everything, all the numbers, are 1, 2, 3, 4, 5, all the way to 12. So S are square numbers and E are even numbers. Complete the Venn diagram. So first of all, what it's best to do, I'd suggest, would be to just highlight over which ones are the square numbers. So if S means square numbers, the first square number is 1, because it's 1 times 1. Next one, 2 times 2 is 4. 3 times 3 is 9. The next square number is 4 times 4, which is 16, which isn't in the list. Now, E stands for even numbers. So the even numbers here are 2, 4, 6, 8, 10, and 12. So we need to put these numbers into the Venn diagram, and we do that by seeing which go into which category. So the square numbers only, will belong in this bit of the square circle. So this would be 1 and 4. What horrible handwriting. I'll just get rid of my writing actually. So 1 and 4 would go, so not 1 and 4, 1 and 9 I said, would go here. Now 4 is both square and even, so 4 would go into the overlap section, because it's both square and both even. This bit here is reserved for numbers which are both square and even. And the other even numbers, we'd have 2, 4 we've got, 6, 8, 10, and 12 in any order. Now, an easy mistake to make with Venn diagrams is to leave out the numbers which aren't square or even. But whatever isn't square or even, whichever numbers I've not underlined here, they go on the outside of the circles, but within the square. Remember, E means everything, so everything somewhere needs to go within the diagram. So 3, 5, 7, and 11 somewhere need to go in. And that's the diagram completed. It now says one of the numbers is chosen at random. Write down the probability. P stands for probability here. S, sort of N symbol, E. Now, that symbol means intersection. Again, what does intersection mean? All it means is the bit of the diagram where the circles overlap. So S intersection with E is a bit of a circle where they overlap. The overlapping bit is the bit with a 4 in it. So one of the numbers is chosen at random. How many numbers are there? Well, there could have been 12 numbers. How many are in the overlap? There's only the number 4, so there's only one number out of a total of 12 that's in the overlap bit. So the probability would just be 1 over 12. Question 23. A coin is rolled onto a grid of squares. It lands randomly on the grid. To win, the coin must land completely within one of the squares. So Mira and John are playing this game. It says work out 2 different estimates for probability of winning. What we can do to estimate probability is use the actual data we've got. So the most obvious for 2 different estimates would be to estimate using Mira's data and then the second one could be John's data. And so based on Mira's data, probability of winning, she wins 6 games out of a total of the total number of games. If she wins 6 and loses 44, the total number of games is 6 plus 44, which is 50. So 6 out of 50, we can write this down as a fraction. 6 over 50. So that's one estimate of probability we could have. So she's played 50 times. John, though, has played more times. John's won 28 times out of, well, he's played 28 plus 72, which is 100. So he's won 28 times out of a total of 100 games. And as a fractional probability, that's 28 out of 100. So those are 2 possible estimations of probability. You could simplify them down if you wanted to, but for probability you don't need to stress as much about simplifying down the answers unless the question asks you to. Now, for part B, it says which of your estimates is the better estimate for the probability of winning. So we had 2 in our case. It was Mira and John. Now John's estimate will be more reliable. Reason being, John's played more games. The more time an experiment or a game's done, the better and more accurate the results. So the answer for this would be John's data, which is 28 out of 100. So the fancy way of explaining this is results become more accurate with a greater number of trials. Trials just means how many times an experiment or a game is repeated. Question 24. In a sale, the original price of a bag was reduced by 1/5. The sale price of the bag is £29.40. Work out the original price. So if something has been reduced by 1/5, if we knock 1/5 off, if we take 1/5 off, you need to think how many fifths are left over. If you take 1/5 off, what that means is 4/5 remain. And so the sale price of a bag, which is £29.40, that equals 4/5 of the original price. So the way to picture this, or a way to picture this, would be to just imagine this pentagon represented the price. The full pentagon would be the full price. The red parts represent the sale price, so 4 parts out of 5. So 4/5 of the price is the sale price, which is £29.40. 4/5. So what we could do of working out, if 4/5 is £29.40, how much is each one of these little pieces? How much is just 1/5? So to go from 4/5 down to just 1/5, what we'd need to do would be to divide by 4. So 4/5 is £29.40. Each one of these little coloured in fifths we can find out by dividing this amount by 4. So £29.40 divided by 4 is what we need to do. So £29.40 divided by 4 equals £7.35. And so each fifth is £7.35. How many fifths make a whole? Well, 5/5 make the whole. So the full price would be represented by a full pentagon. So the full price, which is 5/5, would be £7.35, the price of each fifth, multiplied by 5. So the final step now is £7.35 multiplied by 5, which is £36.75. £36.75, and that is actually the final solution. That's the final answer. £36.75 is what it must have cost to begin with. Now this question is actually very, very similar to what's known as a reverse percentage question. So I'm just going to go slightly off tangent because it might be relevant in future for you. 1/5 as a percentage. You don't need to listen to this bit if you really don't want to. The question's done. But just for information, 1/5 means 20%. And so we can think of this question as the original price of a bag was reduced by 20%. So what I'm going to do, I'm just going to cordon off a little area of the screen so I can just explain this alternative way to you. So imagine it said reduced by 20%. If 20% comes off, that means 80% would be left, so 80% remains. And so the sale price of £29.40, if the question had have given it to you as a percentage, would represent 80% of the original price. From here, we could work out what 1% is. To go down from 80 to 1, any number divided by itself is 1. So we could divide 80 by 80 to find what 1% is. But if we divide this side by 80, we'd need to do exactly the same to the other side and divide this one by 80 as well. And so £29.40 divided by 80 would tell us what 1% of a price is. So 1% would be 0.3675. 0.3675. Then once we found 1%, we can use that as our builder-upper and find whatever we want. So to go from 1% to 100%, we can just multiply by 100. So if we times by 100 on both sides, we can find out what 100% the original amount was. So 0.3675 times 100 would give us £36.75, like we found out before. Now, as I say, this bit is above and beyond what the question's asking for. I just felt it worth a mention, just linking in how different aspects of maths relate to each other, and also just to remind you how you might tackle that question if it was worded slightly differently as a percentage question. Question 25. Which of these is not used to prove that triangles are congruent? Side, side, side. If all the sides of two triangles are the same, they've got to be the same. Side, angle, side. That does prove that two triangles are the same. So that one does. That one does. If you know two sides and the angle trapped between the two sides of two triangles, they will be the same. But this one over here, angle, angle, angle. Now, what I'd try to picture is an equilateral triangle. All the angles are the same in an equilateral triangle, so you can have a smaller one, 60, 60, 60. That's got angle, angle, angle. And this one over here, this one has all the angles the same. So same angles, angles the same, that angle's the same, the top angle's the same. Are they congruent? Remember, congruent means identical. Obviously they're not. If the angles are the same, the shapes will be similar, but they're not congruent necessarily. So they're clearly not identical. So for that reason, if all the angles in a shape are the same, it's not a proof of congruency. So we need to circle this one. Question 26. We're told that E is at the centre of rectangle ABCD. So using the fact that E is in the middle, what we can do is just imagine a line coming off to the side and going up towards D. Now because E's bang in the middle of this rectangle, we know that it's exactly halfway. So the bottom bit here, all the way across the rectangle would be 20, but because E's only halfway, we know therefore that this bit here must be 10. That'll be 10 centimetres. And equally, because E's in the middle, it's halfway down too. Now, the full width of a rectangle is 12. And so this little bit over here will be 6. Now, that's a right angle. We know two sides. We want to find DE, which is the longest side. All the clues are coming in place now. This is going to be a question involving Pythagoras' theorem. It was a triangle question, and we're not bothered about any angles. All we know it's a right angle. We know two sides and want to find the third side of a right-angled triangle. It'll be Pythagoras. So it's Pythagoras' theorem. And what Pythagoras says, well, he said it a long time ago, to be honest, is that the two smaller sides squared, so 6 squared plus 10 squared, if you square the smaller sides and add them together, they will always equal the longest side, in this case DE squared. It's often given as a squared plus b squared equals c squared. So we can use our calculator to work out what 6 squared plus 10 squared is. So 6 squared plus 10 squared equals 136. And so 136 equals DE squared. Now the final step for Pythagoras is always to do the square root. And so DE will equal the square root of 136. So on our calculator, what we do is we type in the tick button first. That means square root, then type in 136, press equals. That's in third form, so press here, and then round off the answer to a suitable and sensible degree of accuracy. So 1 decimal place would do. If you're not sure, you can put down the whole number, but that's probably excessive. So to 1 decimal place, it'd be 11.7. That 6 would round up to a 7 because it's next to another 6. So to 1 decimal place, this one would be 11.7 centimeters. So DE is 11.7 centimeters, correct to 1 decimal place. Question 27. Circle the equation of a line that is parallel to y equals 5x minus 2. Okay, parallel. If two lines are parallel, what it means is they have the same gradient. So I'm just going to make a note of that. Parallel means the same gradient. Now, the standard form of a straight line is y equals mx plus c. And in that case, lines written in this format, the gradient is whatever value, whatever number, whatever thing is written before the x. And so the m would be the gradient. But m can be anything. M just means whatever's in front of the x. And so for this line here, because it's written in the form y equals mx plus c, this one's got a gradient of 5. This one's got a gradient of 2, which isn't the same. That one has got a gradient of 5, so that one is parallel because it matches with that one. This one isn't the same, and minus 1/5 definitely isn't the same as 5. And so the one with the same gradient is just the one with the same number in front of the x, which is this one. So this is the question answer we need to circle. Y equals 5x plus 2. Question 28. This is a tricky ratio question. The number of boys to the number of girls at a school is 9 to 7. So for every 7 groups of girls, there's 9 equally sized groups of boys. So we can illustrate this in terms of a picture. Not that you'd have to, but I quite like doing. So girls on the bottom and boys at the top. So the boys seem to look like gingerbread men cuttings, and the girls have their arms behind their backs, presumably. So 9 lots of boys, my apologies, and 7 lots of girls. It now says there's 116 more boys than girls. So a ratio splits things into equal parts. 9 equal groups of boys, 7 equally sized groups of girls. But there's more boys than girls. So the groupings are the same here because I've lined them up the same. But if you notice, in the numbers as well, there's 2 extra groups of boys. So those two extra groups must account for the difference. These two extra groups of boys must mean that these two groups of boys represent the 116 more boys that there are. So these two groups of boys, two lots of boys, must equal 116. So each group of kids, each group of boys or girls, must be 116 divided by 2, which we can calculate. 116 divided by 2 is 58. So what that tells us is that each group is 58. So how many groups do we have in total? We could just do 9 plus 7, which is 16, of course. Or what we could do is just imagine each one with a 58 over it. So each group is worth 58. I could carry on, but it might get quite tedious. So anyway, each equally sized group therefore represents 58. How many groups do we have? Well, in total, we've got 9 plus 7, which is 16 lots, or 16 groups of 58. And so the total number of students will be 16 multiplied by 58, which we can work out here. 58 times that by 16, 928 students. So how many students are at the school? Final answer is 928. Question 29. Circle the equation with roots 4 and -8. And so when it says roots, what it means by that is the values of x which solve the equation. And so we're saying which one of these 4 has a solution where x is 4 and x is -8. So what we're going to try is x being 4 and x being -8 for each of these and see if it equals 0. So let's get the calculator to the handy. So this one here, if x were 4, 4x would be 4 times 4, which would be 16. In the bracket, x minus 8 would be 4 minus 8 equals -64, so that's definitely failed already. That doesn't equal 0 for both of them, it doesn't even equal 0 for one of them, so that's not that one. This one here, x squared minus 32, does that equal 0? Well, if x were 4, 4 squared minus 32, no, that doesn't equal 0 either, so it's not going to be this one. How about this one, perhaps? So just copying it in exactly as it appears. X is 4, so let's try 4 first. So 4 minus 4. Four plus 8. That does give an answer of 0. But it says roots plural, so 4 works, but we need to try it for -8 as well. So let's just go back and edit out the 4. Let's try -8 for x as well as 4. So -8, and change out x being 4 to x now being -8. So let's see if this will equal 0. Perfect, it does. And so this one works. That one does have, whoops, wanted a green tick, never mind. So this one is the equation which has these roots in it. It works for both 4 and -8. These two brackets end up being equal to 0 when multiplied out. The very last question, question 30, a pattern's made from two similar trapeziums. So similar means one is an enlargement of the other. So I'm just going to highlight similar. So one is an enlargement of the other. Now it's hard to see how they're similar because the big one is like the smaller one got bigger but also flipped upside down. So what I've done is I've imagined the big one flipped the right way up as I'd see it. At the minute it looks not right somehow. So I have to flip it up like this. That 18 would be at the bottom, and that side which is 10 would be at the top. So we know that one is an enlargement of the other, so it's obvious that the big one is an enlargement of the small one. What we could do with working out is the scale factor of enlargement. Now the scale factor of enlargement can be worked out by taking a side on the big shape and dividing it by a side, a corresponding side, on the small shape. So which two sides do we know for both the big one and the small one? So we know, for any one we know in fact, for the small trapezium, is the top thinner side, which is 4. And that corresponds to this side over here, which is 10. So for scale factor for enlargement, the side of a big shape is 10 divided by the side on the smaller shape, which is 4. So 10 divided by 4, that will tell us the scale factor of enlargement. 2.5. So what that means is that the big trapezium, the grey one, is 2.5 times bigger than the small one. And so to go from the small to the big, what we do is multiply each length by 2.5. That means they're going the other way, from the big shape to the small one. Going the opposite way, we do the opposite thing and divide each length by 2.5. So using this now, we can work out the length of this side of the smaller trapezium by taking 18 and dividing it by 2.5. And the reason that works is because this side of the big one corresponds to this side of the small one. So if we do 18 divided by 2.5, that will tell us the bottom side of the small trapezium, which is 7.2 centimeters. We could also do with knowing the height of the smaller one. Now, we know the height of the biggest one, which is 25 from top to bottom. So the small one, to go from the big to the small, we divide the big length by 2.5 to scale it down. So the height of the smaller one will be 25. Again, divide by 2.5. 25 divided by 2.5 equals 10. And so this height is 10 centimeters. Now the area of a trapezium isn't the easiest formula on foundation tier, but there is a recipe, if you like, for finding the area of a trapezium. You can just use a formula and plug the numbers in, but I'll show you how you can do it as a recipe, as it were, step by step, to work out the area of a trapezium. The first step is you add the top and bottom sides together. Add the top and bottom. The second step, once you've added the top and bottom, is you divide by 2, you half it, and your final step is you multiply by the height of it. So, step 1, we add, divide, then we multiply. So, I need a bit more space, so I'm just going to scroll down slightly. And we can consider now the area of big trapezium. So for the big one, step 1, add the top side and the bottom side together. So for the big trapezium, 10 plus 18 equals 28. Step 2, we divide that by 2. 28 divided by 2 equals 14. Final step, we then multiply that by the height of it. The height of a big one is 25. So final step, 14 times 25 equals 350, I believe, 350. So the area of a big one is 350 square centimetres. Now we do the same formula for the small one. So for the small trapezium, this is a hard question, by the way, make no mistake. So if you're finding this tough going, you can be forgiven. It isn't easy, I don't think. Area of a small one, use the same formula with the small one's numbers. So add the top and the bottom. For the small one, the top and the bottom is 4 and 7.2. So 4 plus 7.2, that comes to 11.2. We then divide that by 2, so 11.2 divided by 2. And that comes to 5.6. And finally, multiply by the height of it. So from before, we worked out the height of the smaller one was 10. So the final step, 5.6 multiplied by 10 is 56 centimetres squared. We want to work out the shaded area. So the shaded area, you can think of it as being the whole shape. So the whole of the big one, which is 350 cm squared, with the little one cut away from it. So it's like 350 with the 56 cm squared one, with the little one just cut away and taken off. And so the shaded area will be 350 take away 56. And if we work this out on our calculator, 350 take away 56, we get 294, which is what we wanted to prove all along. 294 centimeters squared as required. So that proves it, and that wraps up our final question, and therefore the complete exam paper. So I hope you found some of those questions at least useful, albeit maybe not all of them easy. And good luck revising, revise hard, and I wish you all the best on exams day.